Hello and Assalamualaikum. So I'm going to continue with the lecture. So before we proceed to the chapter 10.4 over here, so I'm going to recap a little. I want to actually add some information about linear and non-linear differential equation as well as homogeneous and non-homogeneous equation. So what is the significance of this difference between linear and non-linear is linear equation actually a very useful equation because it has simplifying properties. So it is easier to solve a linear equation compared to non-linear equation. So we have learned about the difference between linear and non-linear equation. So I don't want to repeat what I have taught you in previous lecture. And also, so now we go to the different the significant different between the difference between homogeneous and non-homogeneous equation. Actually, this categories is about linear equation, linear differential equation only. So in linear differential equation, we can categorize them into homogeneous and non-homogeneous. So as I taught you before, homogeneous equation, which means linear homogeneous equation, when we arrange it according to the standard, where the dependent variable, every dependent variable at the left hand side, if the equation is equal to 0, which is at the right hand side is equal to 0, nothing, no component at the right hand side, so that means the equation is homogeneous. And when there is something at the right hand side, whether it is an equation include the independent variable or the right hand side has a constant, that means it is a non-homogeneous linear differential equation. Okay, so that's all I want to recap. So now we go to the chapter 10.4, solving differential equation. So now we want to solve the differential equation. We go straight to the first example in the chapter, which is example 10.6. Okay, so we have a differential equation dx dt equal to negative 4x. So this is a little different compared to partial derivative, like I taught you before, because we consider not only the first derivative right here, but we have the original x right here and its derivative. So sometimes we also can include the second derivative in the equation. Okay, so this is the one example of ordinary differential equation. So how to solve this is one way is we need to know the formula. So we can assume an equation which is x in terms of t is equal to e power of negative 4t, so exponential negative 4t. So when we consider this equation, we know that we want to relate to the equation above. So when we differentiate this, we know that the answer will be almost similar to the equation right here. So when we differentiate it, the answer is 4e exponential negative 4t. Okay, so this one, when we compare this equation, this answer with the top equation right here, so negative 4x equal to negative 4e power of 4t. Okay, so now we can compare, because the form is almost similar, and now we can eliminate, simplify it, so that we can have the equation of x in term of t. Sorry. This happen all the time. So x in term of t, this is equal to e power of negative 4t. Okay, so this is the solution. So this is the solution. Alright.